so today we're going to cover the rest of the notes on section 6.5, and today we're going to graph the tangent graph. Now, when we graph the tangent graph, the only thing we're going to change is the cycle length, or maybe an amplitude. We're not going to shift it up, we're not going to shift it down, we're not going to have a phase shift. And we're also not going to graph cotangent. So we already saw the graphs of cosecant and secant, and then we did 2 examples, and now it brings us to the tangent curve. Normally, when we graph sine, cosine, secant, cosecant, the period length was 2 pi. Now, for the tangent graph, the period length is only pi. And again, we're going to find our additional points by finding 1/4, 1/2, 3/4, just like we did when we just had the speed change for the sine and the cosine. So our tangent graph is going to take on the shape of the x cubed graph. Unless there's a negative amplitude, then it's going to take on the shape of the negative x cubed. And the x cubed graph looks like this, up this way and down. And then the negative x cubed graph is like a reflection, it flips. So this is the shape that the tangent graph will take on. Just like with the secant and the cosecant, we're going to have asymptotes. Now, when we go to calculate the key points, the point that we get from the 1/2 is always going to be an asymptote. And then we're going to box it in, and then that's where our other asymptotes or our viewing window will be located. So again, just like before, if you wanted to see how you can tell where it's going to hit the x-axis, you can do these calculations again. This is pi over 2, pi, 3 pi over 2, 0 and 2 pi. This is the order pair 1, 0, 0, 1. And then here, 0, negative 1. So let's say I wanted to do tangent of pi, y over x. Pi is right here. 0 over negative 1 simplifies to 0. If you look up at your graph where we find pi, notice it's hitting the x-axis because our value of tangent of pi is 0. If I were to do tangent of pi over 2, again, y over x, 1 over 0, undefined. At pi over 2, we've got an asymptote. So this is how you can use those ordered pairs to figure out where your asymptotes are located. So let me go ahead and just regraph this basic tangent function, and then I'll do one where it's got an amplitude or a speed change. So let me add a slide. So let's say we wanted to graph just y equals tangent of x. So what I'm going to do is I'm going to the normal cycle. Notice here, my b value is just a 1. So normally we would take 2 pi for all the other graphs and divide it by the b value. But in this case, you take pi and divide it by that b value. But my b value here is just 1. So I'm going to take pi, find 1/4, 1/2, 3/4, and then just the whole cycle, 4 over 4, so it's just pi. So I have pi over 4, pi over 2, 3 pi over 4. These are going to be my key points along my x-axis. So now, let me go ahead and put all my x and my y-axis here. 1 and negative 1 along my y-axis. And then I'm going to add in pi over 4, pi over 2, 3 pi over 4, and then just pi. Over here, negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. So what I'm going to do is I'm going to box this in and pretend like this is the viewing area on your calculator. At the 1/2 calculation, this is always going to be an asymptote. So I'm going to go here, draw my asymptote, draw here on the negative pi over 2. And then now, at the edges of my boxes, I put a point at 0, 0. I'm going to put a point on the on the x-axis. And then now I take on the x cubed graph. So this would go this way. This is out of my viewing area, so I don't show that. And then here, here, and then here. This would be out of my viewing area. And there's your graph. So on this slide, it just has the instructions on what you can do in order to graph. However, you can read through them, but I'm just going to walk you through. So again, the normal cycle for the tangent graph is pi. So the 2 here is my amplitude. I'm just going to label this along my y-axis. Here, this is my b value, and this tells me it's going to go 4 times as fast. It's going to go faster. So I take pi, and I divide it by that b value. So it's pi divided by 4. I now need to take, this is going to be my period length, and I'm going to break it into quarters. So pi over 4 times 1/4, pi over 4 times 1/2. After I get this calculation, this is where my asymptote is going to be located. So then pi over 4 times 3/4, and pi over 4 times 4 over 4. Okay, so I'll multiply. This gives me pi over 16. This gives me pi over 8. This gives me 3 pi over 16. And then this could simplify, and it just pi over 4, because this is 1. So now let's add this to our x-axis. These are our key points. These are the right, and then the left is exactly the same, but they're negative, because there's no phase shift here. We're not going to do phase shifts for tangent.
No phase shift?
Not for tangent. So pi over 16 is the first one. Pi over 8, 3 pi over 16, and then pi over 4. Over here, negative pi over 16, negative pi over 8, negative 3 pi over 16, and negative pi over 4. Add in your amplitude, the 2 and the negative 2. And again, I'm going to box it in. I'm going to show my window viewing area here. So my graph is going to be right in here. I'm going to add in my asymptote at the 1/2. So the middle of the box here is an asymptote. And then now you'll put a point. So you're going to add a point on the x-axis at the edge of the box at 0, 0, and at the other edge, and then draw in your x cubed graph. So up this way. This part again is out of the box. We won't show it. Then here, using those asymptotes as a guide. And then here, and then here.
The test you want to box it out.
Yep. Now, so technically what we do is we have an ordered pair here at pi over 16. And actually it should hit the amplitude. So really your point should be right here. So it really should skim that. And then same thing here. At the pi over 16, it should be hitting that point. Mine are a little spaced out. But if you box it in, you just put a point on the x-axis at the edge of the box and at 0, 0. Now the next one is going to be the negative x cubed graph, because the amplitude is negative. It's a negative tangent graph. So it's going to be flipped, like a reflection.
And then will the...
So this time, here is my amplitude. This time it's going slower. So I'm taking pi, dividing it by 1/2, keep, change, flip it, and it becomes 2 pi. I take 2 pi, and I'm going to go ahead and find 1/4 of that, 1/2, which is where my asymptote will be.
Always do that.
Always do that. 2 pi 3/4, 2 pi 4/4. which is just 2 pi. This will simplify, and it becomes pi over 2. This becomes pi. This is where my asymptote is going to be located. And then multiply this, becomes 3 pi over 2. And those are my key points that I'm going to put on my x-axis. And then I'll put the negative of these on the left side. Let me go ahead and draw my x-axis and my y-axis. So pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And this one had an amplitude of 3 and negative 3. I'm going to box it in. Here is my viewing area. I'm going to add in my asymptotes at the halfway point, which is at pi and negative pi. Add in my points along the x-axis at the edge of the box at 0, 0, and this edge. And again, this has a negative amplitude. So what we're doing here is my first point. It should be going down here at negative 3, and it skims along. And then this one would have been here, and it skims along. And then over here, and this is out of the viewing area. And then same thing over here. This is in it, but this would have been out of it. So technically there's an order pair here at that first point, up at the amplitude. And then you would connect it and skim it along the asymptote.